Welcome to Brain Vision.
Okay, so in this problem, we are dealing with a guitar string, and the length of the guitar string from its bridge to the closest fret is equal to 21.4 centimeters. And the highest note that, when you pluck the highest string, the note that it makes has a frequency of 2,349 hertz. So I'm labeling these as L1 and F1 because they correspond to each other. And then the next highest note that the guitar is supposed to be able to play has a frequency of 2,217 hertz. And from this information, we're supposed to figure out how far away the next fret should be from this first fret that plays the highest note. So first thing we want to do is we want to figure out the length of string required to play F2. And so the way that we do that, we'll start with the equation. F is equal to V over lambda. In this situation, the strings are bound at both ends. At the bridge, it's held so that there's by the bridge so that there is a node there, and then with the frets, it's held at the opposite end as well, so that there's a node at both ends. So that means that lambda is going to be equal to twice the length of the string. So we can say that F is equal to V over 2L. And then we can set up a ratio. So we can put F1 over F2. And that would mean that V divided by 2L1 would be over V divided by 2L2. And we can say that the speed of the wave is the same because the material of the string has not changed at all. So naturally, the V's cancel, and then the 2's cancel. And then if we evaluate the fraction and simplify it, we get the L2 flipped to the numerator and the L1 stays in the denominator. So we end up with L2 over L1. And then what we're interested in is the length of the string that would play the slightly lower note, which is L2. So if we solve this equation for L2, we get that L2 is equal to F1 times L1 over F2. And we have all of that information, so we can go ahead and solve for L2. And so F1 is equal to 2,349 times L1. We want to put L1 in meters. They gave it to us in centimeters. So in meters, it is 0.214. You divide that by F2, which is 2,217. And if you calculate that out, you will get that the length of this, that would make this slightly lower note, is 22.7 centimeters. If you calculate it out, you will get 0.227 meters, which then if you convert it back into centimeters, you get 22.7, obviously. You have some decimals after that, which you'll want to keep for this next calculation, because the answer that we're looking for is not just the length of the string that would make F2 happen. We're looking for how far away this next fret has to be from the first fret, which means we need to take L2 minus L1. So L2 minus L1 is equal to 22.7 minus 21.4. And like I said, there are some extra decimals after 22.7. So we will end up, because we have three significant figures, we will end up with something in the hundredths place, even though we don't have any when we're just looking at these numbers right now. But if you keep all the decimals from your previous calculation, you should get that this next fret will be 1.27 centimeters further from the first fret. And that's our answer.